Okay, let me consider here. So let me have a problem like this, right? So here you can able to see there are lots of things like here. So you have an angle which is 30 degree, and you have a length of this rod is around 3 meter. Okay, and you have a force which is 5 kilonewton, which is at an angle of 45 degree with respect to horizontal, right? So they also mentioned this or something, so which is 75 degree, something like that. So this 75 degree is what we identify as D, something like this. Okay, so which is the best way? So only way to solve this is we have to resolve this, right? When we resolve it, we can easily identify what is the values. Okay, as I told you before, so whenever you have an inclined force, you resolve it, right? So that is not only that case. There are two cases you have to consider. First one, inclined force, you resolve. Right. Second case, even inclined distance, that also you resolve. Right. So what I am saying here is, so it is 30 degree here. It is 30 degree here, and this distance is around 3 meter. In that case, if I draw a line here, an horizontal line and a vertical line, right? So I am resolving this 3 meter in terms of x and in terms of y. So if I resolve it in terms of x, what I will get? I will get 3 cos 30, right? In terms of y, if I resolve, you'll get 3 sin 30, right? So what is 3 cos 30? It is 2.59. 3 sin 30 is 1.5. You know that. So because sin 30 is 1 by 2, so we'll get it. Now, similar to this, I am going to resolve my force also, right? Sorry. Sorry. So resolving this force, resolve it into horizontal and vertical. Okay, horizontal 5. When I resolve this, so 45, bring it to this side, your angle is decreasing, so it will be 5 cos 45, and this side will be 5 sin 45, right? Of course, what is cos 45? 5 is cos 45, 3.53. So same will be for this also. So this will also be 3.53, right? So we resolved it. All the forces we resolved, and we got everything in terms of kilonewton, and we also resolved the distances. Now I can take my moment. Let me take moment at O. So how many forces are here now? Now we have two forces, right? One is 5 cos 45, other one is 5 sin 45, right? For this 5 cos 45 angle, this is horizontal force, right? So your angle should be your distance should be a vertical distance, right? So this vertical distance is this one, which is 1.5, right? So, and how it is rotating? It is rotating in clockwise, right? It is rotating in clockwise. Okay, so minus 3.53 into 1.5. Okay, so why that 1.5? Force into perpendicular distance. Perpendicular distance for this horizontal force is vertical distance, right? Now for this vertical force, right, their perpendicular distance is 2.59. Vertical distance, right? Perpendicular distance is 2.59. So in that case, so that is also rotating in clockwise, so it is minus again 3.53, right? 3.53 into 2.59, right? So what is your value now? Yeah, Yes, what's the value now?
$14.43, sir.
So it is 14.43 kilonewton meter, or I can write it as 14.43 kilonewton meter in clockwise rotation. In clockwise rotation. Okay. So this is the answer for this. So even though you have an inclined distance and inclined force, whatever it is, you resolve both. You make it simple, make it as horizontal and vertical. Find out accordingly. So we are taking another problem which is related to some application-oriented one, right? So you have to draw a free body diagram for a foot lever as shown in the figure. You can able to see here. You have a foot lever here, right? So the operator applies a vertical force, right, in the pedal. So you're applying a vertical force, and you have a spring. You have a spring here which is stretched for 15 mm, and the force on the link AB. So they are mentioned what is the force here. So this 100 Newton, right? So I have to draw the free body diagram here, and they have to take identify accordingly, right? Okay. So this is my free body diagram, right? So this for reference. Don't get confused. Pretty long question just to know how it is applied, right? So all the distance are given, right? All the distance are given. So it's just 10 mm, 15 mm, and you have a spring, other things, and you have a force applied like this, right? So you have one force acting here, another force which is acting here, and of course it's a hinge support, right? It's a hinge support. So whatever we discuss in unit 1, same thing. So whenever you have a hinge support, you have two reactions, which is Rx and Ry. So you have two reactions here, right? So this is my free body diagram, right? They are given that length of the spring del is stretched to 15 mm, right? Okay. So let us identify what is the tension in this force, right? So force is equal to, so you know that we can identify what is our stiffness of the spring. Stiffness is equal to force by deflection. So we are identifying, right? So the spring stiffness is nothing but, so it is 20 into 15. So 15 is the overall stretching, which is del. There is nothing but del. So final length minus initial length, that value is here. Okay. So you know what is the stiffness. From that we can identify what is the force, right? So now we are equating it. So we are getting 100 Newton here, 300 Newton here, and you have some AXA1. My question is, what will be the force F to apply? Right? So these are the forces which is on your pedal, right? So in the pedal இவ்வளவு force act ஆகுது, right? இப்போ நான் எவ்வளவு force pedalக்கு நான் press பண்ணா இது வந்து lever வந்து work ஆகும், right? That is what the principle is, right? That is what we are going to identify. So now what I can say that it is in equilibrium state, right? So in that case I can put sigma fx is equal to 0, right? Note the direction is changed, it doesn't matter. Even if you consider the right side direction, it doesn't mean it will directly go for opposite direction. Okay. Okay. Sigma fx is 0. So when I do that, what will get? So 100 plus 300. So if this is plus ax is equal to 0, ax on the minus low, which means opposite direction, right? Doesn't matter. You have ax, which is 400 Newton. We identified, right? Now sigma fy is equal to 0. Right? Sigma Fy is equal to 0. What will get? Ay, which is this force, and F, this force is equal to 0. Can you able to solve this? According to this case, it is not possible to solve because we don't know what is your Ay and you don't know what is your F, right? So, but if you go for an equilibrium condition, sigma fx 0, sigma Fy 0, and moment at any point is also equal to 0, right? So usually where you take moment where you have maximum unknown force, you take moment, because if you take moment at that point, all that force will become 0. For example, if I take moment at A here, Ax and Ay is unknown actually at the beginning stage, right? That means you can easily avoid these two forces, right? So I'm going to identify what is moment, right? What is moment at A and equal to 0. If I take moment at A and equal to 0, right, you can able to see force into perpendicular distance rotating in anti-clockwise. So F into 50 minus 100 into 15 plus 10. So total distance is 25. So 100 into 25. Why it is negative? Because it is in clockwise direction, right? And 300 into 10, right? These are the forces. I am equating to 0, right? When you do that, now I can able to identify what is the force F value, which is equal to 110 newtons. So these are other applications. So you can able to see in your bicycles, right? So you are going to apply a force of 40 Newton, right? So in a brake lever. So what they are asking, what will be the tension T, right? So what I have to do, I have to take moment, nothing, right? So when I take moment, so which point I have to take moment, right? So I am going to take moment at point O, right? If I take moment at point O and equate it to 0, what happens? This T, it is rotating in anti-clockwise. So T into 22, right? T into 22. And this is also in anti-clockwise. Sorry, this is in anti-clockwise. This is in clockwise, right? So 40 Newton is in clockwise. So distance is 88. So minus 40 into 88 is equal to 0. That's it. So I can identify what is my tension T. So it is 160 Newton. Right? It is 160 Newton. Right? That is my tension T. So yeah, this is like you have a brake handle, right? In which you can able to see in cars, something like that. Winch brakes. Right. You have a force which is 8 Newton, which is acting on the lever, right? And let me consider it is 5 degree, and you have a tensile force here, which is acting here. Okay. So what I have to do is I have this force, I have to resolve this force. So I am resolving this. Similarly, this inclined force, I am resolving it again. So these two forces I am resolving, these two forces I am resolving, right? So these are all comes under moment problems, right? So what I have to do, I have to take moment, right? Which point I will take moment? Let me take moment at any point, right? So I'm taking, I will equate it sigma fx is equal to 0. And it is in equilibrium state. If I say sigma fx is 0, right? So you are having here 8, this is 8 cos phi, right? 8 cos phi, right? And this one is T cos 15. Yeah, they called us P. Okay, so okay, P cos 15. And this is a ball and socket joint. It is like your joystick. Wherever you have a joystick, something like this, you will have OX and OY, two forces, just like your hinge support. Okay, so OX plus this is equal to 0. Similarly, sigma Fy is equal to 0. I am equating it. I am getting like this. And I am taking moment. Where I am taking moment? I am taking moment at point O. Right? So how to take moment? So one by one, each force. This force, 8 cos phi, your vertical distance up to O is 188 plus 75. Right? So it is rotating in clockwise. So I can write as 8 cos phi into 188 plus 75. Right? Rotating in clockwise, negative. Next, this force, if I consider this force, you have a distance here, which is 25. Rotation, it is in anti-clockwise. right? So plus 8 sine phi into 25. For these two forces is over. Next, this force, let me consider this force. Horizontal force, vertical distance, 75, right? T cos 15, the vertical distance is 75, rotating in clockwise. So minus P cos 15 into 75, all right? Next, vertical force, horizontal distance. Horizontal distance is 25. Again, it is also mentioned, right? So rotation, it is also clockwise. It is also rotating in clockwise. So minus P sine 15 into 25, right? You equate all these sides as 0. So you have only one unknown, which is P. You can directly identify, right? So when you solve it, you will get it, right? This is another problem. So you have a hand truck, right, which is used with two kicks, right, which means kicks is this things, right? So you have something like this. Each is having a mass of 40 kg, right? So you have to identify what is the vertical force P, which you have to apply so that it is in equilibrium state. If I say equilibrium state, it is at resting state. It should not move, right? Something like that. So, and what will be the reaction of the wheels, right? So, since you have a wheel, right, how many forces will you be having? Reactions. So, it is having contact. We have only one, V1. Okay, because if you apply in X direction, it will move, right? So, there is no reaction. No reaction in X direction. You have reaction only in Y direction. Okay, so this is my cake. So all the dimensions are given. So I am identifying this is my reaction, and there are two forces. One is 392, another is 392. What is the 392? 40 kg. I am converting to Newton. So 40 into 9.81. When you do that, you will get 392.4 Newton. Right? These are my forces. Right? I think now we consider here. So some more in a bigger way. So I have force P, right? I have force P, but all my distance are inclined. You know that? I have told you there are two options. One, where you have to resolve whenever you have inclined force. The other is you have to resolve whenever you have inclined distance. Here the distance are inclined. Your forces are verticals, right? Here also you have force, reaction force By. All are vertical, but your distance is inclined. The inclination is around 35 degrees with respect to horizontal. So what I will do, I have to resolve that. Okay, I have to resolve that. So I'm just drawing it a line with respect to that, resolving it, right? So what we'll get, so I'm also similarly drawing another line with respect to this, and drawing another line with respect to this. Why I am doing this 3? Because P என்ற distance வந்து பாத்தீங்கன்னா இந்த எல்லாத்துக்கும் கவர் ஆகும். 500 plus 350 plus 80 எல்லாமே கவர் ஆகும், ரைட்? ஒவ்வொன்றும் ஒவ்வொரு லொகேஷன்ல இருக்கிறதுனால we are identifying something like this. Okay, so அதே மாதிரி இதுக்கு டிஸ்டன்ஸ் இந்த 300 எதெல்லாம் இன்க்ளைண்டா இருக்கோ for everything we converting to horizontal and vertical, right? So for all these things, this is 35 degree. For this alone 300 இருக்கு இல்லையா, vertical இது வந்து vertical 35 degree, right? Hope you can understand. Are you clear? Are you clear in this?
Yes, sir.
Yeah. So the vertical distance, அப்போ வந்து இந்த 35 வந்து vertical தான், perpendicular means vertically it is 35, right? Okay, I can resolve this, right? So when I do that, okay, but I made some animation, it is not proper. Okay, right. What I do, I have to resolve all these things, right? So what, let us identify, this is 500, so this is 35. So what will be this distance? 409.5. Okay, similarly, so don't change it, let it be. So 350 cos 45, this one. We can identify 350 cos 45. Similarly, 80 cos 45. Similarly, 300 cos 45. All we have to identify. Yeah. 350 cos
Sir,
45.
286.70.
280.
286.7.
286.7. Okay. So for 80 cos 40, so cos 35.
So 65.5.
65.5. Similarly, 300 cos 40, cos 35.
So 245.7.
245.7. Note, I am writing this vertical because all these are horizontal distances. This alone vertically because it is inclined vertically 35. Okay. Right. Now we are going to identify for sine 35. Right. So 500 sine 35. 500 sine 35.
So it's 286.7, sir.
286.7. Okay. So 350 sine 35. 350 sine 35.
200.7, sir.
200.7. Okay. 80 sine 35.
So 45.8, sir.
45.8. Okay, 45.8. Okay, 300 sine 35.
So 172.
172.
172.07. Okay, good. So now we identified all this force, right? What I have to do, I have to identify. Let me say that it is in equilibrium state, and I can say that let me take moment at point B. Let me take moment at point B. Right? There are three forces. Right? There are three forces. One is P, other one is a force at G2 and force at G1. Note what we discussed in previous slide. You have that two forces, right? 392.4, that two force, that also you should consider, right? So in that case, so moment at D, I'm taking for this force P. So P is a vertical force, right? I need distance up to point B, right? So can you identify what will be the distance up to point B? This it is nothing but distance, right? I need distance from here to here. This distance is 409.5 plus 286.7 plus 65.5 minus 172.07. What I do, I have to identify. So what will be the distance? Can you identify what is the distance here? So subtract all this. So add it and subtract with respect to this. So you will get what is the distance. So this force is acting, it is rotating in anticlockwise. So P into that distance. What is that distance? 589.6. So you are getting 589.6, right? Minus, right? This is anticlockwise. So others are clockwise. Minus, I think 392, right? It is 392 or something else. Yeah, 392.4. Right? So minus 392.4. I am identifying for G2, right? So vertical distance, vertical force, horizontal distance, 286, right? I write it here. So it is 286.7 plus 65.5 minus 172.07. So what is the value? 8.13. Okay. Into 118.13 minus again 392.4 for this force. It is just opposite. So 172.07 minus 65.5. So why I am putting an opposite side doesn't matter because I don't want negatives. Right? It should be a positive distance value. That's it. So 65.5 minus 170 put a negative arrow, right? But we need only differences. Okay. So into what is this? So 106.57. So this is equal to 0. Right now I have only one unknown force P. You can identify what is the value of P. Right? What is your P value? Just substitute it. You can get what is the value of P. Right? So there are some problem which looks easy but a little bit complicated. Right? A little bit you need some training in this to identify how to identify the distances and vertical distance and horizontal distances. Right? Okay, very good. It is 149.7 Newton. Right? So that is the required force to hold this on that particular position, right? Without having rotations and other things, right? Okay.